Hello students, welcome to AP Calculus. In this video, we are going to cover the one of the important test, which is called the limit comparison test. Before that, we have covered the direct comparison test also, so it is quite similar to that. Let's start with this. Here, what does this theorem says? So the sigma an, this term will be given to us, this particular series will be given to us, and we have to assume this series on our own. Just like we have done in the direct comparison test, one of the series will be given to us and one of the series we have to assume from our own, and the term should be positive. Now we just have to calculate this limit an divided by bn. An is the given term and this bn is the assumed series, and we have to assume this series in such a way so that we know its nature, whether it is converging or diverging, and we need to calculate the limit n tends to infinity for an upon bn. Now when we are going to calculate this thing, we are going to have three possible results. The first result which we can have is about this part: if the limit comes out to be between 0 and infinity, like we can say finite as well as positive. Now if the result comes out to be finite and positive, so we have both the series behave in the same way. Suppose the assumed series, if the assumed series converges, then our given series also converges. If assumed series diverges, then our given series also diverges. That is the first result. Second thing, suppose if limit comes out to be 0. Now our limit was limit n tends to infinity an upon bn. If this comes out to be 0, it means the bn is a larger term, right? This indicates that bn is significantly larger as an, because if the n is going toward infinity, the denominator is getting very large. That is why it is going towards 0. So bn is greater than an. Now this is the result of the same direct comparison test. Now we know bn is greater than an. So if bn, let's say, converges, if the larger series converges, then the smaller series has to converge, right? This was we have done in the direct comparison test. And if the larger series diverges, if the bn diverges, then we cannot comment upon the an. The test is inconclusive because an can be diverging or it can be converging also, just like in the direct comparison test. Similarly, the third result is if it comes out to be infinity. If the limit an divided by bn comes out to be infinity, it means an is increasing at a faster rate. Here an is significantly larger than the bn, that's why the answer is going to be infinity. So an is greater than bn. So again, using the same result of the direct comparison test, we can say if this is the smaller one, right, this is greater, this is smaller, so bn is smaller this time, and we know the nature of bn. So if the smaller one diverges, let's say this is the bn, and if this is diverging, then the greater one an has to diverge only, then the an must also diverge. But if the smaller one converges like this is the bn which is converging, so in that case the an may converge. It can be, an can be like this or an can be like this, so it can be converging or it can be diverging. So again we will say test is inconclusive. So basically we are going to use this first result in this case. In most of the cases we are going to use the first result. If it is between 0 to infinity, then we will have the same nature for an and bn. So some important points over here. We have to make sure that the an and the bn must be positive. It means they should have the positive terms. And whenever bn we are assuming, whatever series you are assuming, we have to compare it with such a term so that we know its nature already. Generally we assume a p series or a geometric series, and if the limit does not exist and is not infinity, then the test cannot be applied. Okay, now look at the first thing. So first result over here, we determine whether the series is converging or diverging. So we can compare, this is our an, 1 upon n square minus 5. So let's say I am assuming the bn is 1 upon n square. So this is 1 by n square. So I know this particular series, this is p series. Using the p series, here p is what? Greater than 1. P is 2, which is greater than 1. So this series converges. Now we just have to calculate limit n tends to infinity an upon bn, and we'll see what this result shows. So an is 1 upon n square minus 5. divided by 1 by n square. Dividing by 1 by n square, it will become n square by 1, and we'll calculate this limit. Now you know, when we are calculating this limit in which numerator is a polynomial, denominator is a polynomial, degree is same for both of them. If the degree is same, then the ratio of leading coefficient is the answer, which is leading coefficient is what? 1 and 1. So 1 is the answer. Now since 1 is greater than 0 and finite also, therefore both have the same nature. Both have the same nature. So you can say, since the Bn converges, therefore An also converges. So this particular series converges this time. A very easy approach. Let's look at the second question. We need to compare, determine whether the series converges or diverges. So what is our An over here? 1 upon 3 power k minus 5. So let us say I'm assuming the Bn is only 1 upon 3 power k. Okay. So here it is, okay, actually it is using k over here. So let's say ak. And here it is also bk. So 1 upon 3 power k. Now we know that 1 upon 3 power k, it's the geometric series. Here, what is the, according to geometric series, what is r? R is 1 by 3. So we can say, since r is lying between minus 1 and plus 1, therefore it converges. If the r is greater than 1 or less than minus 1, then it diverges. Right now it is converging. So now let us do one thing. Limit k goes to infinity, where we can use the k also or n also. K goes to infinity, ak is 1 upon 3 power k minus 5 divided by 1 by 3 power k. Dividing by 1 by 3 power k, so 3 power k will go in the numerator. Now to simplify this particular limit, we can take the 3 power k here. Take the 3 power k as common. So it is 1 minus 5 over 3 power k. Now this 3 power k will cancel. Now since the k is going toward infinity, so if the k is going toward infinity, so this is going to be very, very large. So 5 upon 3 power k will go towards 0. So finally we are left with 1. Now 1 is again greater than 0 and finite. Therefore both will have same nature. So we can say, since Bn converges, therefore An also converges. Let's look at the next example. So this is the An given to us. The An is square root of 2n square plus 4n plus 1 divided by n cube plus 9. Let us assume the Bn. Let's take the first term from here, square root of 2n square, and from here the first term n cube. If we simplify this, it is square root of 2n, since n is positive over here, so it is only n, divided by n cube. On simplifying, this will become by n square. So according to the P series again, because you can treat it as root 2 1 by n square. Now according to the P series, since n is greater than 1, so therefore it converges. Now we know it converges. So therefore we will calculate limit n goes to infinity. The An is the same thing, 2n square plus 4n plus 1 divided by n cube plus 9 divided by the Bn. Bn is square root of 2n square by this thing. Or on simplifying, we are getting square root of 2 by n square. So when we are dividing by square root of 2 by n square, it will get reciprocal. It will become n square by square root of 2. Now we just have to calculate this limit. So to simplify this thing, what we can do, from this square root, let's take the 2n square as common, or simply n square we can take common. So if you take the n square as common, so we'll be left with 2 plus 4 over n plus 1 by n square whole divided by, this is n cube plus 9, and n square by square root of 2. And the limit n goes to infinity. When we take this n square out of the square root, it will become absolute value of n. And since the n is positive, so it will become only n. Absolute value of n will open with n. So it will become limit n goes to infinity, n. In the bracket will be having 2 plus 4 by n plus 1 by n square in the square root, 2 plus 4 by n plus 1 by n square dividing by n cube plus 9, and that is n square by root 2. Now if you multiply n and n square, So it will become n cube, and here we are left with 2 plus 4 over n plus 1 over n square. Now from the denominator also, from this n cube, we can take the n cube as common. It will be 1 plus 9 by n cube multiplied by square root of 2. N cube will get cancelled out. Now since the n is going toward infinity, so this 4 upon n will become 0, 1 upon n square will also become 0, 9 by n cube will also become 0. So we are left with root 2 from the numerator and 1 times root 2 from the denominator. So basically we are left with 1. Now since 1 is again greater than 0, positive and finite, so both will have same nature. So we know that Bn converges. So since Bn converges, therefore An also converges. That is how we can comment upon the nature of the An. We are not comparing which is smaller, which is greater. We are just assuming Bn and take the limit of the ratio. That's how we have to perform the limit comparison test. Two of the result of this limit comparison test, like these two results, rule 3 and the rule 2, are same as the direct comparison test. So mostly we are going to use the first rule over here. When it is going from 0 to infinity, we will have the same nature. So I hope you have understood this part. So if you have any doubt related to the AP calculus, please connect with me on this WhatsApp number. And if you like this video, please subscribe to the channel. Thank you for watching this.